Hey guys, so today we're going to be starting off with deformation, right? Now, what is deformation? Why exactly does it happen? What are the key things that we're going to be going over in this chapter? So, earlier on, we did study the chapter of forces, we did study what a force can do, and the most important thing that we're going to be dealing with is the aspect of the force where it has the capacity or it has the effect of changing the shape of an object, right? So when we talk about what a force can do, you can say that it can change the shape of an object. Can change the shape of an object, the force. And when we're dealing with deformation, we're obviously going to be doing an example with the help of a spring. So let me just quickly go ahead and draw a spring for you. Just 1 second. Alright, so let's say we've got this spring over here, which I've labeled the diagram 1. Alright, this is what the spring initially looks like. Right, now let's suppose I apply a force and I pull the spring in this direction. Okay, so I'm pulling the spring in this direction on the right hand side. Now this diagram number 2 that you can see over here is what your spring would look like when the force is exerted. When you're stretching this, when you're pulling this spring towards yourself, you see that there is an extension. You will see that there is extension in the spring, right? Now this is basically what deformation is. Deformation is the temporary change in the or the process of deforming or the change of shape in an object, right? Now this is what we call extension. Right, now we've got another this is extension. We're going to talk about permanent and temporary extension deformation later on, elasticity and all of that, but right now you just need to know what two types of effect forces have, which we are only concerned with in this chapter, right? So this is what extension is, this is what an extensive force is. Okay, you can also write that here. So when we've got an extensive force, you will see that there's an extension in your in the string, right? Similarly, you've got spring number 1, actually diagram number 1, all right, and over here, as you can see, that you've got a spring which is already, there's already extension over here, and what you're doing is you're applying the force in the opposite direction. You're basically pushing the spring. All right, you are applying the force on the left hand side, all right, in the left direction, and you're pushing the spring inwards. Right, now what's happening is that there's compression, right? The size of the spring it has decreased, right, or the length has become smaller. All right, now this is what we call compression. Okay, and compression, and over here this is what we call the compressive force. There you go. Now let's see. Okay, now let's talk about elasticity or elastic deformation. Now what is elastic deformation? Now whenever force is applied and the shape of an object is changed, the moment you release that force, the moment that force is removed or the moment that force is taken out of the equation, what happens is that the object regains its actual original shape. Right, now this effect in itself is called elasticity, or we call it elastic deformation, right? So in this case, let's suppose if we talk about the first diagram, you're applying the force, there is extension, as you can see in the second diagram. What will happen is, let's say I let go. Okay, let's say I'm letting go. What will happen is that the force, you will see that your spring has just come back to its actual original shape. Alright, now this effect is what we call elastic deformation or elasticity. Alright, so it's going from diagram number 1 to showing the extension, and when the moment you let go of the force, Don't let go of the spring, or when when there's no force, this is what you will see. On releasing the force, it will come back to its original position, right? This is what we call elasticity or elastic deformation. I'm going to write down the definition for you guys as well. Just give me 1 second. There you go. That's what the definition of elasticity or elastic deformation is. Let me write that down as well. Elasticity. Now, so it'll go like, when a force is applied, then the shape of an object can be changed, and once again, on releasing the force, if the object regains its original shape, then again we call this effect elasticity or elastic deformation, right? Now there's one small concept of elastic limit or the limit of proportionality as well, which we'll talk about. Now I'm sure you guys have observed, you guys have seen that when you apply a certain amount of force to an object, you will see that it's coming back to its actual shape, it's coming back to its original shape, right? But in some cases, when you overexert or when you're applying a much greater force, you will see that the object is permanently deformed, or you can see that it is not going back to its original shape, or the way it was, right? It is permanently deformed. It's now never going to go back to its actual original shape, right? Now what happens is that there's this thing that we call the elastic limit or the limit of proportionality, which is the maximum amount of force that you can apply before the object in either it either breaks down or it either deforms permanently, right? So it can be either two of these things, right? You will either see that the object has deformed, it has changed its shape forever, all right, or you will see that the object will break at the very next moment, right? Now this limit or this point, where this point is basically what we call your elastic limit or the limit of proportionality, right? This is the limit or the maximum limit of force that you can apply to an object before it permanently deforms, or it it loses its elastic properties, or it either breaks in some cases, right? Let me write that down for you as well. There you go. Elastic limit or limit of proportionality is the maximum extension in an elastic object after which it either breaks or deforms permanently, right? So we're going to go over a graph so that I can explain this to you guys. Now the graphs that you will see over here for this chapter will be extension load graphs or extension force graphs, or they will be extension force and extension graphs, and vice versa. Let's see. All right, now let's say I've got the extension force or the extension load graph, which extension over here is in centimeters, force is going to be newtons. We've got these equal intervals. Now, so for the first part, let's say this is point A, this I'm going to call point B, and this will be point C, right? Now point A is when you've got no force being applied on the spring and there's no extension for that as well, right? Now the moment you increase the force, you apply 5 Newton force, you see that there's a 5 centimeter change, right? There's a 5 centimeter in of extension. You see, you apply 10 Newton force, there is a change of 5 centimeters again. You go for 15, you see 5 centimeter change. You go for 20 newtons, you will see that there is a change of 5 centimeters as well, right? So over here from point A to point B, you can say that the force is directly proportional to your extension. X over here is representing extension over here. Okay, now whenever the force and the extension are directly proportional to each other, or when there is an equal amount of extension for an equal change in force, you will say that the Hooke's law is being applied over here, or the Hooke's law is being obeyed. Alright, now what is the Hooke's law? Why do we talk about it? What exactly is it? So it is basically this relation in itself, right? Whenever if the object is if it is within the elastic limit, all right, the extension which is produced in an elastic object is once again always going to be directly proportional to the force which is applied. All right, let me write that down for you. Okay, now this is what we have for the Hooke's law. What is the Hooke's law? The Hooke's law states that within the elastic limit, the extension which is produced in an elastic object, once again, is directly proportional to the force which is applied. Now, we say that whenever there's an extension, whenever there's force applied, there's an extension observed in the length of the spring as well, right? But what does Hooke's law say? It says that whenever there is whenever there's seeing that if an object is within the elastic limit, the force and the extension in the string will be directly proportional to each other, right? So that means that with an equal change in force, there will be an equal change in the extension or the change in length as well for that object, right? Now, what is this k over here that you see? F, we already know that stands for the force. X over here stands for the extension. All right, now I'm sure if you guys take math, you'd know that this is the sign for proportionality, right? And whenever you replace this with an equal to sign, you get k, which is your constant. All right, so your equation will look something like this: f equals to kx. All right, now what is this x? We call this the constant, or if we tailor it to this chapter, we will call it your spring constant. Okay, there you go. Now this is what we will be using for our numericals, where we're supposed to find out different lengths, we're supposed to find out different extension for different forces, that too with the help of your graph, right? Alright, now point A to point B is when the Hooke's law is valid, where when there is an equal amount of extension with an equal change in the force, right? Now from point B onwards, you see that there is slight change. When we increase 5 Newton force, you will see that there is maybe an extension of 4 centimeters. Okay, so it goes from 20 to 24, maybe 23 and stuff like that. So from 25 to 30, when you increase your force to 30 newtons, you will see that over here there's an even smaller amount of extension. You will see that there's a 2 centimeters of change in the length, right? Now this is the part where you can say that your there is no equal change in the in the length with an equal change of force, right? Now point B over here, since this is the point where your extension is not directly proportional to the force which is applied, you will say that point B is when your elastic limit has reached. This is the limit of proportionality, okay? And let's write down for A and B over here as well. So A to B, let's say A is when your Hooke's law is valid. C is the elastic limit, as I just told you, and B is the elastic limit, I'm sorry, and C over here is what we call your breaking point. C is what we call your breaking point. Now why do we call it your breaking point? So that is because, once again, when it crosses point B, when it reaches the elastic limit, and if you keep on applying a force, there will come a point when the object will permanently deform, which is from point B and onwards. Alright, C is the point when you apply such great amount of force that your object will completely break. Okay, there is it'll completely shatter, just like so if you want to further categorize or further describe these different points, you can say that from point A to point B there is elastic deformation, where the Hooke's law is valid, which means that once again, if you are applying a force, there is equal amount of extension, and the moment you let go of that force, the moment you remove that force from the equation, what happens is that the object will regain its actual position or the actual shape, right? But if you talk about from point B to point C, this is when there's permanent deformation happening. All right, now so yeah, that's about it. Next up we're going to be doing circular measure for this chapter. All right, and once again, very small part of the same thing, few things to know, and that's about it. All right.